example 23, we're asked to find and interpret the integral from 0 to 60 p prime of t dt. Here p prime of t is given by this formula. It's the amount of it's the growth rate of bacteria in organisms per minute, t minutes after they're introduced, given by this formula. So here we go. The integral from 0 to 60 of p prime of t dt would be the integral from 0 to 60 of 35 e to the 0.007 t dt. The 35 is a constant. I could move that out front. Now remember, folks, that we could go through a formal u sub here, but we do know that the integral of e to the kt dt is 1 over k e to the kt plus c. These things come up often enough. So we're going to go ahead and use that formula. So this is going to be 35 divided by 0.007 e to the 0.007 t evaluated from t equals 0 to t equals 60. So we've got 35 over 0.007 times e to the 0.007 times 60 minus e to the 0.007 times 0. And we'll fire up Desmos here to help us with some of these calculations here. So 35 divided by 0.07 is 5,000. 60 times 0.07 is 0.42. So this is equal to 5,000 times e to the 0.42 minus e to the 0, which is 1. And this would be a time where we would probably want to approximate, because we're looking at the number of organisms per minute. So we fire up Desmos here, approximate what's going on. And if we round that to the nearest organism, it's 2,610. And so what this is talking here, we're integrating the rate. So remember, this is going to be the net change. Oops. So that's going to be the same as the difference in population after the first 60 minutes or first hour. So this says that there are 2,610 more bacteria after 1 hour. Okay, 60 minutes, 1 hour. Now we don't know how many bacteria there are initially. They haven't told us that yet. So we don't know how many there are total at that time, but we do know the net change is 2,610. So there's, after an hour, there's 2,610 more bacteria than when we started. The initial number of bacteria is 5,000. Find a formula for the population of bacteria, P of t. So this is where we go back and use our net change. Our P of t is going to be our initial amount, P of 0, plus the integral from 0 to t, P prime of u du. So we've got 5,000 plus the integral from 0 to t, 35 e to the 0.007 u du. And once again, we've done this work. So we're going to have the 35 over the 0.007 times e to the 0.007 t minus e to the 0.007 times 0. And we know that this is 5,000. So, or excuse me, yeah, so that's 5,000. So that's 5,000. And we have that this is e to the 0.007t minus 1. So look what happens when I distribute through. These 5,000s cancel out. Oops, got the wrong button there. And so P of t would be 5,000 plus 5,000 e to the minus to the 0.07t minus 5,000. And so we're left with P of t equals 5,000 e to the 0.007t. Now, for fun, we can use this to check our previous answer. First off, we can check the derivative of that. So we can check the derivative there to make sure that that tracks. But we could also fire this into Desmos here. I'll call it P of x. Once again, I just don't trust sometimes. When you use t instead of x, sometimes Desmos gets confused. Let's look at P of 0. There's 5,000. Let's look at P of 60. And let's look at P of 60 minus P of 0. And sure enough, that's the number we had before. Okay, so there's the net change for us using the original P of t. So that'll do it for example 23.